Okay, so today we'll see the uh, how to find the locus of a complex number. So before discussing about the locus of complex number, let's uh, think about the uh, complex number as a vector. See, because locus means it's a geometry. So we discussed in the previous lecture that uh, if we want to think or if you want to solve geometrical problem of a complex number, then we have to think from the 2D vector point of view. Whereas for solving some analytical, we have to look for the Euler form of complex number. See, if you let's say any complex number z1 minus z2, think as a vector. Think as a vector. How to think as a vector? See, let's say this is z1, this is z2. So then this one, okay, as a vector, this is what? This is z2 minus z1. Okay, so you have to think as a vector. So we can say z1 is a position vector of let's say point 1, and let's say z2 is a position vector of let's say point 2. Then what is z2 minus z1 represent? They represent the vector from z1 to z2. Okay, the vector means we know that any vector something this is like this. So let's say this is point is z1, this is point 2 is let's say z2. So this represents z2 minus z1. Same as just like in vector, let's say this is vector A, this is vector B. So B minus A vector represent this one. So starting the we can say the initial point is A and the final point is B. Okay, so this is how we treat the vector. So we can say that the z2 minus z1 is PQ. This is what we can think of a complex number as a vector. So if we think complex number as a vector, it's become easy to understand the geometrical aspects of a complex number. So treat complex number as a vector the way I have explained here, exactly same as the vector. So this particular way, the way I have explained is exactly behaves like a vector. Okay. Since you have an idea about how to think the complex number as a vector, so let's talk about the very basic locus of a complex number, that is mod of z minus z naught is equal to r. Okay, this is a very fundamental locus of a complex number. So here obviously z naught represent, basically this represent the circle, this represent the equation of the circle with z naught as the center of the circle and r is the radius of circle. Okay, so we can think of like this is some kind of a circle with z naught as center and r is radius. So mod of z minus z naught is equal to r represent the equation of the locus of the circle with center as z naught and radius is r. Now we think why it is representing circle. We can think of, see, z1 minus z2. What does this represent? This represents the distance between z1 and z2. It is exactly same as, let's say, any vector. We have, let's say, the vector z1, this is vector z2. We can think parallelly as a complex number and as a vector. So what does this represent? So this is point A, this is point B. So what is AB distance? Vector AB. So vector AB is z2 minus z1, and this mod of z2 minus z1 represents the distance between AB. So z1 minus z2 represents the distance between the complex number z1 and z2. Okay, so clearly if I say z minus z0 is equal to r, that means what? That means z0, let's say somewhere is the z and somewhere is the z0. So this distance between this z and z0 is r, and here z0 is constant, r is constant, but z is varying. So clearly since z is varying, so z can have multiple location where the distance from the z0 remains to be same. So this again we will see here, this z will lie here somewhere, distance will be r. Again z may lie somewhere here, distance is r. Somewhere lie here, z distances are somewhere lie here, z distance are. So the z0 and r is constant, but z is varying such that the distance from z0, the distance remains constant. So that's why mod of z minus z0 represent is called r represent the equation of the circle. Okay. So what is circle? Circle is in case circle the center and the radius is constant. Only it is varying such that distance remain constant from the z0. So that's why this represent a circle. Okay. Let's take for example. Let's say I take z minus 1 minus I is equal to 2. What does this represent? This represent a circle, equation of the circle with center is 1 minus I and the radius is 2. Okay. Okay. Now think of like this. Let's say we can draw it somewhere. So one center is 1, so 1 and I. Let's see, here is center and radius is 2. So it will somewhere here like this. Just a minute. Okay, so this is something like this. So 2, let's say anywhere, let's say this is the point P and this is the Q which is varying. So the PQ distance, the PQ, this is PQ. Okay, distance PQ. PQ is constant, so Z varies. So clearly this Q varies. Q varies. That is the Z varies. Okay, the Z varies. Whereas the P, that is Z0, is constant. So locus of a point Z is a circle with radius as 2, and center is Z0, that is 1 comma minus I. Okay, or we can say center is 1 comma minus 1, the things. Okay, so this always remains to be same. This distance Q is varying. Okay, so this Q is varying, this Q is varying. Got it. But distance, I mean this, what is distance here? This is Z minus Z0, this distance constant. This is Z minus Z0, this distance constant. This is Z minus Z0, this distance is constant. The distance remains constant. Okay, this distance remains constant and the Z varies. So this represents a circle. Okay, one important thing is, you should note down that if I say Z minus Z1 is equal to A, obviously this represents a circle with center Z1 and radius is A. But what important thing is that the A should be real. A should be real. If A is not real, they will not represent a circle. For example, if I say what is the locus of mod of Z minus 1 plus I is equals to 2 minus I. Clearly mod, see, we discussed in the beginning that this modulus Z, this is a pure real number. This is a pure real number. Okay, pure real number with non-negative, okay, so this is pure real but non-negative, that is positive value. So clearly in this case the left hand side is a pure real number, where the right hand side is a imaginary number. Okay, so that's why this locus is not possible. Why? We say that no locus is possible. No locus is possible. Okay, why? Because right hand side is imaginary, whereas the left hand side is pure real. Okay, so that's why this locus is not possible. Okay. Okay, now what does, let's say let's say if I take one example, Z minus 2 greater than 4. So what does this clearly represent a circle. This clearly represent a circle with 2 as a center. So center is 2 plus 0 I or 2 comma 0 and the radius is 4. Okay, radius is 4. We first solve equality. But the Z is such that distance from 2 is greater than 4. So that means obviously it will lie somewhere out, all the regions which is outside, got it, anywhere, somewhere. If I take z here, so distance from z and 2, distance from z and 2 is greater than 4, so z will lie outside the circle, got it. So we can say that the z minus z1 greater than a, it is the region outside circle with center z1 and radius a. Obviously a should be real. Okay, now same way, if I ask you what does this represent, z minus z1 less than a, clearly this represent circle which is inside region. So center is z1, radius is a, but they represent the region inside the circle of radius a. So they represent the region inside a circle with center z1 and radius a. Got it? Okay, now combining both, if you ask a very basic question, let's say what is 1 greater than z minus I less than equal to 3 represent. So basically there are two parts. First is z minus I is less than equal to 3, that means they represent the circle inside the region, and equality is also there. So in this case inequality is there, so it will not represent circle. This case no, so it does not represent circle. Okay, it does not represent, or does not show the circumference. Okay, circumference, it does not represent circumference. See, important thing is, if someone says z minus z1 is equal to a, they represent the circle. Circle means the z lies on circumference of circle. Okay, this the circumference of circle. Whereas if I say z minus z1 greater than a, the z lies outside circle, outside the circle. Okay, but circumference is not involved, but not on circumference, not circumference. Whereas if I say z minus z1 greater than equal to a, then they represent both. So z lies outside circle, including the circumference. They will represent that because equality is there, so circumference will also be there, including circumference of circle. Okay, and same way we can understand z minus z1 less than a means inside. So z lies inside circle, but not the circumference. Okay, not the circumference of circle. Whereas if I say z minus z1 less than equal to a, now z lies inside the circle, including circumference of a circle. Okay, so if I give you this example, we start with this example. Okay, so we talk with example 1 minus mod of z minus I less than equal to 3. So what does they represent? They represent a circle with center as I means 0, 1, and radius is 3. So they represent inside the region, so inside is there, but outside one also. There is one more circle which have a radius 1. So they represent the circle, the region between 1 and 3. So they represent the region between 1 and 3. Okay, so in this case all the region between 1 and 3, but interesting thing is that the equality is 3. That means this include the circumference also. This also is represented, circumference is also represented, but not the circumference of the inside circle. Okay, because there is no inequality here. So we should know that so they represent the, I can say that they represent the, we can write it here, So they represent this particular part represent the outside circle, circumference is not included. Okay, whereas this region I can say that the inside circle and circumference is included. Okay, so we can say what is the locus of this one. So the locus will be the outside the inner circle, that is circle with radius 3, and inside and including the boundary, that is circumference, and including the boundary part of outer circle. Okay, for example, if I ask a very basic question, find the area of region represented by 1 z minus I less than 3. So clearly we know that they represent a circle with center at I and radius is 3. So this is I center. So this is radius is 3. This radius is 1. So they represent this point, this region. So what is the area here? Area will be pi 3 square minus 1 square. Okay, so whatever pi 9 minus 1, that is 8 pi. Okay. Achha, if I ask you one more basic question, find the region, find the locus or find region represented by mod of z minus 2I greater than minus 1. So since this is always true, you should know that this is always true. Whatever I write z is always true. So the locus, what is the locus? So in this case, the locus of z is all plane. Okay, that is complete organ plane. That is complete organ plane. Complete organ plane. Okay. We draw the organ plane. It represents all the organ plane. Doesn't matter where is the center and which circle is it. Because this is always true. This is modulus, and modulus is always greater than a negative value. So this particular part represents the values of z. This is valid for all the values of z. So this represents all the regions of a organ plane. Okay. So this was the basic of the modulus one. Now let's talk about the basic of let's say locus involving or locus of argument of z minus z1 is equal to theta. So involving the argument. See. So let's say if I talk it, what does the argument okay, so now the locus of the argument of z minus z1 is something. Locus of argument is direction. So what does this represent? They represent a ray. Okay, so what kind of ray? So let's take one example. Let's say argument of z is pi by 3. So what does argument of z pi by 3 represent? So there's some complex number z which is located at pi by 3. Okay, so what does z represent? So z is something in terms of vector is something like this. So this is the plot of so what is the plot of the argument of z pi by 3? So basically z are all those points such that its argument is pi by 3. So it is like a array. Okay. Now one important thing is this represents all the values originating from origin to outward direction in the angle of pi by 3 except the origin, except the z is equal to 0. Why? See, if I say z is equal to 1, then argument of if let's say z is here, somewhere here, no? Some point is here, let's say this value is anywhere is like, let's say this is z1, no? So we know that the argument of z1 is pi by 3, it is correct. But if I talk about was the argument of 0, this particular point, argument of 0, if the point or the complex number lies at origin, so this is not defined. This is not defined. That is the essential part. This is not defined. So essentially you should know that the argument of z is equal to any theta. This represent a ray originating from origin and in a direction outward such that its angle is, or its direction is, or its argument is theta. Again, this represent a ray except the original from where it is originating. Got it? So in this case the locus of z is a ray. Important, it's a ray, not a line. Ray from origin. Okay, but origin is not included. That is the important thing. Origin is not included. Origin not included at angle, let's say pi by 3. Since angle pi by 3 is a argument, so it is angle pi by 3 with respect to the positive direction of x-axis. Okay, or let's say from the positive x-axis direction. This is the locus of this. Okay, similarly, let's see if I take one more example. If I say, let's say, by the way, one important thing. If we try to solve this problem with a coordinate geometry, let's say z is equal to pi by 3, we can get this value as tan inverse y by x is equals to pi by 3. So y by x is tan pi by 3. Okay, so tan pi by 3 is root 3. So y is equals to root 3x. So by looking at, or by converting into coordinate form, and then we try to draw, so then it will represent a line. Okay, this represent a line, but argument of z pi by 3 does not represent a line. It only represent the which is going outward direction in the first quadrant, not in the second quadrant. Why? Because the argument of this line, this ray, is pi by 3, whereas the argument of the line or the ray, the part of the line which is on the third quadrant, its argument is pi plus pi by 3. Okay, or in terms of principal argument, if you want to write in terms of principal argument, this value is pi minus pi by 3 minus 1. So essentially what I want to say that they are asking to draw the argument of that pi by 3. So it's a pi by 3 only. It's not that pi by 3 and pi plus pi by 3. So essentially if you try to solve with the coordinate geometry, you turn out to be a line. But if you solve this with the concept of complex number, then they are a ray. Got it? So see, argument of z is equals to pi by 3. If I will plot, so you should know that this is the plot. Let's see plot. But this form, this is the this plot is argument of z is equals to pi by 3, whereas this downward side is the argument of z is equals to, we can write 4 pi by 3 or pi plus pi by 3. Got it? So different. Argument of z pi by 3 is not a line, it is a ray. Okay. Okay. So okay, let's take one more example, then we'll explain things. Okay, let's say what is the argument of z minus I is equals to minus pi. Got it? See, if I have to tell what is the argument of z minus z1 is equals to alpha, what does it mean? It means somewhere is the z and z1 and somewhere is the z. Okay, somewhere is the, so this is z, this z1. So what does z minus z1 represent? Z minus z1 represent this complex number, or it's a vector. We already discussed in the previous lecture that it's easy to solve a complex number if you treat them as a vector. So this is z minus this, so this is basically z minus z1. Okay, and if its angle from the positive direction is alpha. Got it? So z minus z1 represent a ray originating from z1 and moving in a direction such that the angle or the argument of that ray is angle alpha with respect to the positive direction of x-axis. Got it? That's the important things. So someone say, what is the argument of z1 minus z2? So you have somewhere is z1, somewhere is z2. So z1 minus z2 means, okay, what about z1 minus z2? So z1 minus z2 will be like this opposite direction. Got it? Because if you look at, someone say this is, let's say in vector, you know that let's vector p and q. If I say what is the vector pq, or let's say OP minus OQ, okay, sorry, or just OQ minus OP. This is how we write the PQ. So that means it will be somewhere like this, okay. So same way here also, z1 minus z2 will be in this direction towards the z1, okay. And if its angle is alpha, so we'll see if it is, let's say this is x-axis, and the angle will be, this is alpha, or if we want in a clockwise sense, otherwise this is alpha. We will take this alpha, okay, not this alpha. This alpha is not considered, this is wrong, okay, this is wrong, not this alpha. The alpha is this one, because this is direction is from z2 to z1. Got it? That's why this alpha will be considered. Okay, now let's come to our original problem. So I don't know where is z, but we know I is somewhere here, okay, and they are making angle minus pi, okay. By the way, minus pi in terms of the principal argument is not possible, but in terms of the general argument is possible, okay. So minus I is possible. You don't think that, okay, because we are talking the general argument, and z is such that the angle is minus pi. So somewhere here only, somewhere we can say that the z will be this side only, then only its angle will be minus pi. So they represent all the ray originating from I and moving towards the left hand side except the I itself. So will not include, again I am emphasizing, the z is equal to I is not in locus, okay. So basically what is the locus? So locus is the ray as shown excluding z is equal to I. Z is equal to I is not included, okay. So we can write one concept. Someone say, what is the argument of z minus z1 is equal to alpha represent? So how will draw it? So we will take somewhere, let's say this is the z1 and angle is alpha, somewhere let's say this is z. So z minus z1 is this one. This is z minus z1 as a vector, we treat as a vector. So what is alpha? Alpha is, this is parallel to the x-axis. So this angle is this angle is alpha, okay, this angle alpha. So what is the locus? So locus, you should know that the locus is a ray originating from z is equal to z1, not including z1 and so it is originating from z is equal to z1 and moving, because ray moving along or at an angle of alpha. Again, what is alpha? Important. What is alpha? Alpha is taken with respect to positive direction of x-axis. We already discussed this part in the previous lectures, where we defined how to check the argument of a complex number. Okay, so let's take one example. Okay, one more example. Let's take this one. Let's say argument of z is less than pi by 4 and greater than 3 pi by 4. What does this represent? So again this represents some complex number z such that there are two extreme points. One extreme point is argument of z is pi by 4, that is we can say this pi by 4, and this is pi. Another is argument of z is 3 pi by 4. So other is argument of z is 3 pi by 4. They represent this one. So now this has a 3 pi by 4. So what does this represent? They say that all the argument between 3 pi by 4 and pi by 4. So it may be argument of z may be pi by 2 also possible. So this one. So it represent all the reasons, all the values of z where the argument is between 3 pi by 4 and pi by 4. Okay. If it, let's say the point is here, let's say this is z. So we can clearly see that the argument of z in this case is greater than pi by 4 but less than 3 pi by 4. So they represent all the values which is lying between the ray which is along pi by 4 and between the ray which is along 3 pi by 4. Okay, so this is what does they represent. Okay, let's solve one problem. So if I say find area of region formed by z satisfying z minus 2 minus I less than 4 and greater than 2, and pi by 12 argument of z minus 2I less than equal to 5 pi by 4. So we'll draw both the reason. First of all, this reason is this and means it's a intersection. Okay, so z minus 2I. So what does this represent? Z minus 2 minus I between pi by, so first we'll draw the pi by 4 and this is what z minus of, we write like this, okay, is equal to 4 because z minus z naught is equal to alpha. This is minus here, so we'll write like this. Okay, and other is the z minus 2 plus I is equals to 2. So they are lying between the circle of radius 4 and radius 2. So let's draw this one. So 2 plus I, 1, 2, I. Somewhere is the center is 2 plus I. 2 plus I is the center. So we'll draw a circle with radius 4. So that's this is a circle with the radius 4. So this has a radius 4. And other circle with radius 2. Somewhere like this. Yeah, this is circle with radius 2. So what is this reason? What does this reason satisfies? So basically, so this is the reason which is lying between these two, annular reason. Okay. Okay, so find the area. So but they also have restriction that argument of z minus 2I should be between pi by 12 and 5 pi by 4. So where is 2I? That is 2I. Okay, let's make it otherwise confusing. Let's the question is that z minus 2 minus I. Okay, then it will be easy. So what does this region represent? What does this region represent? So this region represent the same center z minus 2 plus I that lies between 5 pi by 4 and between the pi by 5 pi by 4. Let's make it otherwise confusing. 12. So between the pi by 12 and pi by 5 pi by 12 and pi by 12. Okay. So if you draw this region, how does they look like? Somewhere this 2 originating, the array is originating from 2 plus I and 5 pi by 12. Somewhere is the 5 pi by 12. Okay, and then pi by 12. So then pi by 12. Okay. Let's make it pi by 12 smaller. So let's see this one. So this is pi by 12 and this is 5 pi by 12. So the reason is between this one, between this line ray pi by 12 and 5 pi by 12. Okay. So that means if you want to draw combine together, if we combine these two together, both the condition, I will get the reason is this one originating from, so this is somewhere this is the ray, this is represent argument of z minus 2 minus I is equal to 5 pi by 12, and this region represent the argument of z minus 2 minus I is equal to 5 by 12. So the essentially our required region, we have to find area of this one. This is our required region. Okay, so what is the area? So area will be just annular region. So we have to find this area. Okay, this angle is pi by 12 and 5 by 12 will be 4 pi by 12. So 4 pi by 12 this region, and this is we have to find area. The radius of this is 2 and the bigger is the radius is 4. So this is the reason. So using the area of a sector, so area will be half r square theta. So it's theta is 4 pi by 12, and it being annular region, so we can say it's a 4 square minus 2 square. So it will be 4 3 12. So pi upon 2, 4, 16 minus 4. 16 minus 4. Sorry, it will be 6. It will be 6. 6. So pi upon 6. 12. 12 pi upon 6. So 2 pi. So 2 pi is the corresponding area of this annular region. Okay, here again, see, here I have used we know that if area of the sector, this is theta, and this radius is area of the sector will be half r square theta. Mind you, theta is considered in the radian, not in the degree. And since we want an annular region, so we can also find that so we can easily find the r1 square minus r2 square. Okay, so essentially you should know that I have used the area of a sector using this particular formula, half r square theta. Okay, so now we have done up to now. We should know how to the locus of z minus z naught is equal to r, and argument of z minus z naught is equal to alpha. These are two important locus which will be used frequently even in solving the problem, not just in locus, but even solving problem also we can use. In solving problem also we can use this very powerful locus. So this represent the circle, this represent the ray. Again this represent the circle, but this represent the ray, not the line. Ray excluding z is equal to z naught. Again, z naught will not be included. So here if I want to plot this part, I have every time I have excluded for argument of z minus zi and argument of z minus 2 minus I. Okay, if I exclude this part. Okay, so I'm in the class here, and we'll see next